You have probably saved an awesome list of AI tools to your bookmarks folder for years. It feels like a cheat code that will help you build software faster than everyone else in your team. But in the age of large language models, these curated lists are actually traps leading directly to brittle systems and unmaintainable architectures. A GitHub star count is not a performance benchmark. Relying on popularity without understanding hardware constraints turns your stack into a house of cards, where one API update breaks everything you built. We will reframe how you evaluate tools today so you stop chasing trends and start building for production reality. The first thing we must confront is the phenomenon known as architectural drift. Curated repositories like Macima, awesome. AI tools serve as massive community catalogs, boasting over 5,900 stars and nearly 2,000 forks from developers around the world. These lists aggregate a chaotic mix of generative models ranging from Gopher, with its staggering 280 billion parameters, down to developer utilities that promise instant solutions. While they function as effective signals of current market trends, treating them as static blueprints for production creates severe architectural drift. Engineers who blindly adopt tools found in these directories often build systems that fail catastrophically when the underlying model shifts or specific use cases evolve beyond generic capabilities. The problem is not the list itself, but how we treat it as a source of truth rather than a signal of where the industry is looking right now. We must also address the illusion of static best practices in such a rapidly moving field. Repositories like Owain Lewis, awesome artificial intelligence attempt to raise the bar by enforcing an absolute quality bar and using automated validation for technical depth within their entries. However, even these curated lists struggle with the sheer velocity of large language model development cycles today. The age of LLMs demands dynamic evaluation rather than passive consumption of a static directory. A tool listed as a best practice in January may be obsolete or incompatible with your specific data infrastructure by March due to rapid API changes and model deprecations that happen weekly now. This creates a dangerous false sense of security where you believe you have selected the right stack when you have only selected the most popular one for the current moment. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to the critical shift from simple tooling selection to rigorous evaluation infrastructure. True engineering rigor is found in specialized lists like Benchflow AI, Awesome Evils, which distinguishes itself by rejecting silent inclusion of abandoned projects or tools without evidence. This repository was built on a depth 4 recursive crawl of 11,600 academic papers, rather than just counting stars or pull requests. It emphasizes that evaluation infrastructure must be treated as a scientific method because you cannot trust popularity signals from broader lists if you have no way to verify performance under load. Without rigorous eval processes distinguishing between generic benchmarks and actual evaluations against your specific data, you are flying blind into production environments where latency matters more than feature sets. The consequences of ignoring these engineering realities manifest directly in the stability of your software systems. When a popular library suddenly changes its API or deprecates a core function that your application relies upon, the entire system collapses because it was built on popularity rather than fit-for-purpose analysis. This is why relying solely on star count signals, junior-level thinking during an interview or system design review, understanding trade-offs such as inference latency versus cost or model size versus hardware utilization, signals senior judgment and career readiness. You must stop asking what is the most popular framework in a list and start asking if this tool's latency profile matches your specific hardware constraints like GPU availability or TPU utilization requirements for your use case. For any practitioner, blindly following an awesome list represents a significant career risk that leads to accumulating technical debt over time. Systems built on popularity rather than rigorous fit-for-purpose analysis are brittle and extremely difficult to maintain as the underlying technology landscape shifts beneath you. The practical shift requires you to audit every tool in your stack against 3 specific production constraints before adding it to your architecture. First, check for hardware fit by ensuring the tool's latency profile matches your available compute resources rather than assuming it will run efficiently on any machine. Second, verify versioning stability by confirming that the library is actively maintained and not just a legacy entry sitting in a static list with no recent commits or updates from its creators. Third, establish evaluation rigor to validate performance against your specific datasets instead of generic benchmarks found in documentation. The mental model you need to adopt changes how you view these directories entirely. Instead of viewing them as directories containing the best tools for every situation, engineers must reframe them strictly as signals of architectural drift showing where the industry is looking right now. They are a map of current trends, but they do not guarantee stability or robustness for your specific application requirements. The payoff comes when you stop chasing star counts and start prioritizing AI-specific constraints like inference speed, cost efficiency, and versioning reliability over what looks good on a trending list. This approach ensures that the systems you build today will still function reliably tomorrow, even as the technology landscape continues to evolve at an unprecedented pace. Building robust software in this era requires constant vigilance against the seduction of popularity metrics. You must treat every tool selection as a hypothesis that needs validation rather than a decision based on community consensus alone. The difference between a system that survives production and one that crumbles under pressure is often just the depth of your evaluation process before deployment. By shifting focus from what tools are popular to how they perform in your specific environment, you gain control over your architecture instead of being controlled by it. This mindset transforms you from a consumer of lists into an architect of reliable systems capable of withstanding the volatility inherent in modern AI development cycles. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.